All right, here are the answers for the worksheet from yesterday. This was the 5-8 worksheet on point slope form. You can see 1 and 2, we were just writing equations in slope-intercept form, and we did these together yesterday. 3 and 4 we had also done together yesterday. This was going from point slope form to slope-intercept. We started out with a point and a slope, so we substitute those values into point slope form, and we end up with our answer in slope-intercept form. So there's 3 and 4. Here's 5 and 6. You can pause this if you need more time. Here's 7 and 8. Number 9 we did together. This was going from being given 2 points, finding the slope, then using point slope form to get us to slope-intercept form. And we did do number 9 together. Here's number 10 and 11 and 12. And here's 13 and 14. So you can turn those into the Core 4 basket sometime during class today, and I will take a look at them after school. And now we're going to take a look at your 5.9 notes. So you should have your notes out. We're going to finish Chapter 5 notes up today with parallel and perpendicular lines, and specifically going to look at the slopes of those types of lines. There's a couple of vocab terms in 5.9. The first one, parallel lines. Parallel lines are 2 lines that have the exact same slope and share no points. They never intersect or they never touch. Perpendicular lines are lines that intersect to form right angles, 90 degrees. So perpendicular lines cross one time, and where they intersect, it forms a right angle. Here's a visual of parallel lines. All vertical lines are parallel. Even though the slope of a vertical line is undefined, those lines are parallel. And 2 different non-vertical lines are parallel if and only if they have the same slope. So it's important to know that these 2 lines, the solid line and the dashed line, if they're parallel, they have the same slope and they'll never touch. Please notice they do have different y-intercepts. They have to have different y-intercepts to be parallel. If 2 lines have the same slope and the same y-intercept, then you're in a situation where it's actually the same line twice, and because they're touching and sharing points, they're no longer parallel. You're dealing with the same line twice. Parallel lines cannot touch each other. Perpendicular lines are a little bit different. Perpendicular lines, if you look at them here, a vertical up and down dashed line and a horizontal solid line form a 90-degree angle. All of those perfect 90-degree corners. So vertical lines are perpendicular to horizontal lines. 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. So if you can multiply the 2 slopes together, -2/3 times 3 over 2, and get an answer of 1. So -2/3 times 3 over 2, I would get -6/6, which is -1. So those are perpendicular lines. That means that all 4 of these little angles are 90 degrees. Another note with perpendicular lines is that they have slopes that are negative reciprocals to each other. An example of negative reciprocal would be if I gave you a slope of 4/7, the negative reciprocal would be -7/4. Or if we had a slope to start with of, let's go with 6/11, and let's make that negative. So our first slope is -6/11. The negative reciprocal is 11/6. So if we start positive, we finish with a negative, and it's reciprocal. If we start with a negative, we'd finish with a positive. So with perpendicular lines, you should have one positive slope and one negative slope. To identify parallel lines, we need to put them all into slope-intercept form. So on this line, I'm going to call this line A. The slope is 3. The y-intercept is 2. The next one, I'll call that line B. The slope is negative 1/2. The y-intercept is 4. The next one, line C, this is not in slope-intercept form, so I'm going to subtract x from both sides. That gets me to 2y equals negative x minus 4. Then I'll divide everything by 2. And I get y equals negative 1/2 x minus 2. So the slope is negative 1/2. The y-intercept is negative 2. And finally, line D. This is in point-slope form. I want to put it in slope-intercept form. So I'm distributing that 3 into the parentheses. Then I'm going to add 5 to both sides. And I get y equals 3x plus 2. On this one, the slope is 3, and the y-intercept is 2. So the question was, which lines are parallel? Lines B and C are parallel. They've got the same slope and different y-intercepts. So B and C are parallel. A and D look to be parallel because they have the same slope, but they also have the same y-intercept. So they're not parallel. That's actually a case where we have the same line twice. If we wanted to show that a shape is a parallelogram, we need to find the slope of those lines. AD is a vertical line with an undefined slope. So that's that segment, straight up and down. BC, also undefined. Well, if they're both undefined, they're both vertical. So those two are parallel. If we want to find the slope of AB, we could use the slope formula because we have ordered pairs, but we could also count up to, from here I go up 2 spots and over 5. So that slope is up 2 over 5. And it's positive, that's going uphill. And then for CD, starting here, we go up 2. We still go over 5. So that's 2 over 5. And you've very quickly shown that this shape has to be a parallelogram because it's made up of 2 sets of parallel lines, just by comparing the slopes of all 4 of them. And our last slide for the day, we want to identify perpendicular lines. We need to look again for slopes that are negative reciprocals. Good job. So we're going to compare these again. I'm going to call this one A. Now this one doesn't have a slope. So sometimes it's fun to draw these, graph them, and see what it looks like, because x equals negative 2 is a special line. It goes through the x-axis here at negative 2, and it goes straight up and down. That's a vertical up and down line. Line B, y equals 1. That goes through the y-axis at positive 1. That's a horizontal line. So those two are perpendicular. They form a right angle. So for perpendicular lines, I already know that A and B are perpendicular. Line C, the slope is negative 4, which is also negative 4 over 1. And line D, the slope of this one is 1/4. We could put this into slope-intercept form. And then subtract 2 from both sides. We would get y equals 1/4 x. And this would become negative 1 3/4. But again, the slopes, negative 4 over 1 and positive 1/4, are negative reciprocals. So yes, lines C and D are perpendicular. Your assignment for today is to go into your Schoology, Chapter 5, Section 5.9, and it's the book assignment. So parallel and perpendicular lines, 5.9 book homework. And I would like you to work on numbers 2 and 3, which ones are parallel, 5 and 6, which ones are perpendicular, 9, 10, 11, which lines are parallel, 13, 14, and 15, which ones are perpendicular. So again, that assignment, 5-9 book, you're doing 10 problems, 2 and 3, 5 and 6, 9, 10, 11, 13, 14, 15.